Let us solve the fourth problem. Laplace transform of cos omega t plus beta. Laplace of cos of omega t plus beta. Now, here first we apply the formula of cos a plus b, which is cos a into cos b, that is cos omega t into cos beta minus sin omega t into sin beta. Then by linearity property, I can split. I can say that cos beta into Laplace of cos omega t minus sin beta into Laplace of sin omega t. Cos beta into Laplace of cos omega t will be s upon s square plus omega square minus sin beta into, this is omega divided by s square plus omega square. This equal to 1 upon s square plus omega square into s into cos beta minus omega into sin beta. Now let us find Laplace transform of square root of 1 plus sin t. Here Laplace transform of 1 plus sin t. Now for sin 2t we have a formula that 2 sin t cos t, and for 1 we can apply the formula sin square t plus cos square t. So that concept if we utilize, we can remove the square root term. We haven't seen any Laplace formula which has root term, so we have to remove this root term. So better I write this 1 as cos square t by 2 plus sin square t by 2, and this sin t we will write 2 sin t by 2 into cos t by 2. Now this whole term is in square root. So this will be equal to Laplace of square root of cos t by 2 plus sin t by 2 the whole square will be equal to Laplace of cos t by 2 plus sin t by 2. Now this I will say that is equal to Laplace of cos t by 2 plus Laplace of sin t by 2. Now this cos t by 2 is nothing but cos 1 by 2 into t. So we apply the formula of cos at, which is s upon s square plus a square. Now here a square is your 1 by 2 square, plus here you will say that a, that is 1 by 2 upon s square plus 1 by 2 the whole square. This will give me answer as s upon, now this is your s square plus 1 by 4 plus here it is 1 by 2 I will take out, and this is 1 upon s square plus 1 divided by 4. This I can write as s upon 4 s square plus 1 whole divided by 4. So that whole divided by 4 I will write in numerator, and here it is 1 by 2. Similarly here it is 4 upon 4 s square plus 1. Here also it is 4s square plus 1. Now 4 upon 4s square plus 1, this I can take out, and here I have 1 plus 1 upon 2. Now let us solve the sixth problem. This sixth problem, you pause the video and try to solve yourself. Laplace of this, I will apply the formula of a minus b the whole square. I will get a minus 2 times root p plus 1. Now this I will say that is equals to Laplace of p minus 2 times Laplace of p power half plus Laplace of 1. Laplace of p is 1 factorial upon s power 2 minus 2 times, this is gamma 3 by 2 I will say that, because gamma n plus 1 as half is not an integer, divided by s power 3 divided by 2, and Laplace of 1 is 1 upon s. So this is your 1 upon s square minus 2 into this gamma 3 by 2 is 1 by 2 into root pi as half into gamma half is root pi upon s power 3 divided by 2 plus 1 upon s. This equals to 1 upon s square minus this 2 and half will cancel and I have root pi upon s power 3 by 2 plus 1 upon s. Now pay attention on this seventh problem. We have to find Laplace transform of sine power 4t. We have already learned one method how to expand this sine power 4t in terms of sine or cos. Now I will discuss one more method of expanding this sine power 4t. If you remember, in complex number we have learned one formula, that is sine t can be written as e power it minus e power minus it divided by 2i. So as I am writing for sine t, similarly we have for sine square t, sine cube t, only the power t will change to 2t, 3t, like that. So this sine power 4t, I will say that this is equals to e power it minus e power minus it divided by 2i whole power 4. I will take this denominator term out. So 2 power 4 is 16 and I power 4 is 1. So this is e power it minus e power minus it the whole raised to 4. Here we will apply the binomial expansion and write this as 1 upon 16. Now binomial expansion, first I will write this maximum power for this first term, so e power I 4t, then minus sign is there, so minus, then 4 e power I will reduce one power, so I will say that e power I 3t into e power minus it, then plus next term will be 6 e raised to I 2t into e minus I 2t, then again it's minus 4 e raised to it into e raised to minus I 3t, and last it will be plus e raised to 0t, we can say that, into e raised to minus I 4t. How I am getting these coefficients 1, minus 4, 6, minus 4, 1? So for that I am using the Pascal triangle, which you may have, which you may know that I can write a triangle like 1, 1, then 1, 2, 1, then 1, 3, 3, 1. Now see what I am doing. I am adding these ones and writing here. Then this 1 plus 2 is added here. 2 plus 1 is added here. And this 1 is shifting towards left and right. Now in the same way, continuing in the same way, I can write 1, 4, 6, 4, 1 and so on. Now I have to write the expansion for e raised to it minus e raised to minus it power 4. So I will take this particular row. This is for square, this is for cube, and this is for power 4. So that is why I have written that particular expansion. Now this is going to be, so better I rub this and here only I will continue. So this is going to be 1 upon 16. Now I will club terms like e power I 4t and this last term, which is plus e power minus I4t. The second term is minus 4 e raised to this I3t minus it will give me 2t I2t, and here I have one term minus 4 e raised to minus I2t, and lastly I have 6 times e raised to 0, 2t and minus 2t, that will give me answer is 0. So this I will got as 1 upon 16. Now e power I4t plus e power minus I4t, in one bracket I will take minus 4 times e raised to I2t plus e raised to minus I2t, and here I have plus 6. This is going to be equal to 1 upon 16. Now e power I4t plus e power minus I4t, it is 2 times cos 4t minus 4 into 2 times cos 2t and plus 6. So this is going to be equal to, that 2 I will take out. So it is 1 upon 8 times cos of 4t minus 4 times cos of 2t plus 3. Therefore, we will say that sin raised to 4t is equals to 1 upon 8 times cos 4t minus 4 times cos 2t plus 3. So therefore, Laplace of sin power 4t will be equals to 1 upon 8 times Laplace of cos 4t minus 4 times cos 2t plus 3. This is equal to 1 upon 8 times Laplace of cos 4t will give me answer as s upon s square plus 16 minus 4 into s upon s square plus 2 pi square 4 plus 3 divided by s, and this is finally I will write as 1 upon 8 s upon s square plus 16 minus 4s upon s square plus 4 plus 3 upon s. So one formula which we understood here is, that is sin t can be written as e raised to it minus e raised to minus it divided by 2 times I. Similarly, I can write cos t as e raised to it plus e raised to minus it divided by 2. Now in sin t I have 2i and in cos t I have only 2, and in hyperbolic function I have sin hyperbolic t as e power t minus e power minus t divided by 2, and cos hyperbolic t as e power it plus e power minus it divided by 2. If I have sin at, then I will write e power iat minus e power minus iat upon 2i and so on. So using this formula and binomial expansion, I can write expansions for any power of sine or cos. Now let us solve one more problem. Sine raised to phi t. Okay, again I recommend that you pause the video and solve first by yourself and then check the answer. This is very important problem. So what we do, first expand this sine power phi t. Now as I know, this sine t is e power it minus e raised to minus it divided by 2i. So sine raised to phi t will be equals to 1 upon 2i the whole power 5 into e power it minus e power minus it the whole power 5. This is equals to 1 upon 2 power 5 is 32 and I power 5 is I. So we have written, and this is e power it minus e power minus it the whole power 5. Again we use the Pascal triangle. So in Pascal triangle, if I draw here, it is 1 1, then 1 2 1, 1 3 3 1, 1 4 6 4 1, and 1 5 10 10 and 5 1. So therefore we use this particular column for expansion, and therefore I will say that therefore sine raised to 5 t is equals to 1 upon 32 times I into, here we say that e raised to I times pi t, then minus 5 times e raised to I 3t. Now see here, it should be e raised to I 4t into e raised to minus it that I am clubbing. Then after 5 I have plus 10 e raised to, again it is I t minus 10 e raised to minus it plus 5 times e raised to minus I 3t, and lastly minus e raised to minus I times 5t. Now this is equals to 1 upon 32i e power I 5t and e power minus I 5t. This I will write together. Then I have minus 5 times e raised to I 3t minus e raised to minus I 3t plus 10 times e raised to it minus e raised to minus it. Now this e raised to I phi t minus e raised to minus I phi t can be written as 2i times sine phi t minus 5 times, this will be 2i times sine 3t plus 10 into 2i times sine t. Sine phi t, if you recall, I can write this sine phi t as e power I phi t minus e power minus I phi t whole divided by 2i. So if we rearrange the terms, we will get this particular term. Now here 2i is common, so that 2i we can take out, 2i divided by 32i, and here I have sin phi t minus pi into sin 3t plus 10 into sin t. This is the value of sin power 5t. Now we can find the Laplace of this sin power 5t. So what we will say, that Laplace of this sin power 5t is equals to Laplace of This 2 upon 32 will become 1 upon 16, and in bracket I can write sin phi t minus 5 into sin 3t plus 10 into sin t. This is equal to 1 upon 16 Laplace of sin phi t. I will say that 5 upon s square plus 25 minus 5 into 3 upon s square plus 9 plus 10 into 1 upon s square plus 1. Technically speaking, we have find out the Laplace power 5t, but we can simplify this further. We take 5 upon 16 common. Inside we have 1 upon s square plus 25 minus 3 upon s square plus 9 plus 10 upon s square plus 1. What we do, we make the denominator common. We take the LCM of s square plus 25, s square plus 9 and s square plus 1. So my common denominator will become s square plus 25, s square plus 9 and s square plus 1. In numerator, we write here in place of 1, we write here s square plus 9 into s square plus 1. Now try to understand, as this first term, I want to make the denominator as s square plus 25 into s square plus 9 into s square plus 1. So the numerator I have to multiply by s square plus 9 into s square plus 1. And similarly I can do for rest of the terms also. So my second term will be minus 3 times, it will be s square plus 25 into s square plus 1, and last term will be 10 times s square plus 25 into s square plus 9. We will get 5 upon 16 times. Now if we expand, the first term we will get s power 4 plus 10 times s power 2 plus 9 minus 3 times, in bracket I have s power 4 plus 26 times s square plus 25 plus, I will write here 10 times, I have not 10 times, we say that 2 times, because 5 we have already taken out. So this is 2 times, we have s power 4 plus 25 plus 9, it will give me 34. So 34 times s square and plus 25 into 9, I will have 225. Whole divide by, I will say this whole divide by s square plus 25, s square plus 9 and s square plus 1. 5 upon 16 times. Now we collect all s power 4 terms. So here I have s power 4 minus 3 times s power 4 plus I have 2 times s power 4. Then I collect all the square terms. So I have 10 s square minus I have 3 6 are 18, 3 2 are 617, so 78 s square, and plus I have 68 s square, and lastly I will take all the constant terms. So it is plus 9 minus 75 plus 450, and my denominator will be s square plus 25, s square plus 9, s square plus 1. So this will be equals to pi upon 16. Now see, s power 4 minus 3s power 4 plus 2s power 4. This becomes 0. 10 times s square plus 68 times s square 78 and minus 78. So that will also become 0. So we have only this constant term. Now 450 minus 75 will give me 375, and 375 plus 9 will give me 375, so 380. So it will be 384 divided by this whole term, s square plus 25, then s square plus 9, then s square plus 1. You can use calculator, as calculator is allowed to calculate these values. Now this will be equals to, now this 384 and 16 we can cancel with 4. So I have, or here on left hand side, this 384 and 16, if I try with 4, so 4 9s are 36, 2 24, 4 6 are, this is 4, again with 4 I can cancel, 4 to the 8, 4 4 the 16, and 4 1 the. So what I got in numerator as 5 into 24 divided by, this is s square plus 25, now s square plus 9 into s square plus 1. So finally I will say that Laplace of sine power pi t is equals to 120 divided by s square plus 25 into s square plus 9 into s square plus 1. Now this 120 is nothing but value of 5 factorial. So you can also write this as 5 factorial upon s square plus 25 into s square plus 9 into s square plus 1. In the next lecture, we will see Laplace transform of some more functions.